Now, servers, something that we need to constantly remember when we're talking about servers, is that servers use something called a client server model. All right. And what that means is that on our clients, on our workstation or our tablet or smartphone, whatever it is, we're going to have some kind of software on there, HTTP client software. However, we never call it that. We call it Google Chrome or Firefox or Internet Explorer or Safari or Opera or you name your favorite browser. It is an HTTP client software. And we use that client software to interface with server software, in this case, HTTP server software. And like I said, Apache and IIS are two types of HTTP server software. What we then do is the client, when we want to download a website, the client says, hey server, send me the website. And we send a message called an HTTP GET. And then the server will reply with the website that we're trying to download. This is an extreme oversimplification of what servers do, but it's an important oversimplification to understand. We have to understand that the client is making a request to the server, and then the server is going to fulfill that request and send it back to the client. Let's talk about some networking gear. Our networking gear, we have switches and formerly hubs. All right, switches operate at layer 2 of the OSI model, and hubs operate at layer 1. When I was a tech down in Illinois supporting a paperless project, we used a lot of hubs there, but this was in the late 90s, and a hub at that time, a 48-port hub, might cost $5,000 or $6,000. Okay, today we can't even buy a 48-port hub unless we do some pretty hardcore research and look for a specialty company making them. Today, when we set up data networks in an organization, it's much more likely that we're going to be using switches, and we're going to be using those hubs for some troubleshooting purposes if we need it to. Routers are a second big piece of gear we use in data networking. All right. Routers operate at layer 3 of the OSI model, and they're meant to move traffic from one area of a network into a different area of the world of a network. Okay. We also have something called layer 3 switches. These are just meant to really confuse newbie students who think they finally have it figured out that switches are at layer 2, routers are at layer 3, and then we come and mess it all up and we say, well, here's a layer 3 switch. Well, a layer 3 switch is functionally at OSI layer 2 and 3, right? What it is it's just a router and a switch combined into one single device. As a matter of fact, if you have a high-speed internet connection at home, you most likely have some type of tiny layer 3 switch, because that tiny device you buy so that everybody in your house can use the internet service, that little device is a layer 3 switch essentially. It has a wireless access point on it, it has a little switch on it, and it also has a router on it. Last, we have wireless access points. Right, wireless access points we're going to use to distribute wireless signals. Wireless access points are operating at layer 1, the physical layer, and layer 2, the data link layer of the OSI model. Now, if we take a look at this in the TCP/IP model sense, switches and hubs are operating at our network interface layer, routers are at the internet layer, and layer 3 switches are both at the network interface and internet layers. Wireless access points are at the network interface layer as well. Let's talk about accessing and configuring this gear. Now, for our network gear, routers, switches, and access points and whatnot, all right, we oftentimes will have a direct serial connection to these devices. All right, we call that connection on the device a console port. Sometimes it's called an auxiliary port as well. This console port is using the RS-232 protocol. All right, it's a layer 1/2 protocol to move data back and forth. Serial protocols here are arcane, old, well-used protocols, but they're very slow and kind of clunky to use. So we use them sparingly, and what we usually use this for is to put the base configuration on a router or switch. A second mechanism we can use for Configuring a device is a remote connection. This is the common way that we're going to configure devices. We're going to first use the console to configure the device with a base config, and then once we have the base config on, we can then use something called a virtual terminal. We can use that virtual terminal to connect to the device with SSH or Telnet. SSH is the encrypted version here. Telnet is the unencrypted version. We also have options of out-of-band management. One of the things we used to do at the hospital in order to make our life a little bit easier should a network outage occur is that every single site that we had a device at, we would install a dial-up modem and connect it to the auxiliary port or the console port of the device. And what this let us do is, in the event that the network had a catastrophic failure, what we did is we used the POTS network, the plain old telephone service network, to dial into our router and find out if something on that router might be causing a problem, and maybe I can correct that issue without even leaving my desk. All right, this is especially important if you have to solve a problem in the middle of the night and you don't want to drive halfway across the state to try to fix a problem unless you absolutely have to. Another important piece here when we're accessing and configuring gear is to have some method of accessing the device with a username and password, and then have it determine what we're doing on that device. All right, and that's what we call AAA. All right, AAA here is not the road map service, but in this case, AAA is authentication, access, and accounting. And what it means is that we're going to have a username and password that we use for authentication, just like we do when we log on to a PC. Access, right, is going to be associated with our authentication. So as an administrator, you're going to have a very high level of access that's going to give you the ability to control and manipulate lots of different pieces of a network operation system. Whereas if you are a user, an end user, you're going to have a very limited access. Maybe you just have access to your own email account and your own home folder as a user. As an administrator, you might have access to everybody's email account and everybody's home folder, because you may need to control and manipulate that to help end users get their jobs done. The last piece of that is accounting, and accounting basically is keeping track of who did what when. So we use this AAA system to allow authorized users to configure and monitor and control our network operations gear. Typically, we're doing this with a Radius or a TACACS server. Tim mentioned Radius and TACACS in the previous course, and Radius and TACACS are really just protocols and servers that we can use to handle this authentication, access, and accounting. Here's how our AAA server might work, all right? If I'm the administrator up there on my workstation and I want to change the configuration on my switch, okay, what's going to happen is I'm going to type SSH to my switch. I'm going to SSH to my switch and build a connection. When I do that, it's going to ask me for a username and password. Well, I'm going to type in my username and password. What's going to happen then is that information gets sent to the switch. Before the switch will let my administrator log on work, it's going to send a message to the TACACS server or the Radius server saying, this guy claims he's the administrator. Here's his username and password. Is he authorized? And then the TACACS server or the Radius server will reply back and say, yeah, either accept this guy or reject this guy. Right? So we're using this third-party device to keep track of who's logging into our equipment, and we're also going to log who did what when on those systems.